Look up at the night sky. For almost all of human history, it was quiet up there. Just stars, planets, and the slow drift of the Milky Way. But if you go outside on a clear night now, and you know where to look, you'll see something else. Lines of moving lights marching across the darkness in perfect formation. That isn't a constellation of stars, it's a constellation of satellites. Starlink, one company's plan to surround the planet with tens of thousands of tiny machines, all working together to beam the internet down to Earth. But there's a problem. Every satellite we launch becomes one more piece of metal racing around our planet at bullet speed, and if we're not careful, we won't just connect the world. We could trap ourselves under a growing cloud of space debris. Let's start with what Starlink actually is. Starlink is SpaceX's project to build a massive network of small satellites in low Earth orbit, what scientists call a mega-constellation. Instead of a few big, heavy satellites very high above the Earth, Starlink uses thousands of smaller ones, orbiting much closer. Why does that matter? Because closer satellites mean lower delay, lower latency. It means video calls that don't lag, games that don't feel like you're playing from the past, and most importantly, internet access for places that never had it, remote villages, ships in the middle of the ocean, disaster zones where cables are cut. Starlink promises to reach all of them. It's one of the most ambitious communication projects humans have ever tried, a web of hardware built on pure engineering. But ambition always comes with a cost. And with Starlink, that cost is measured in objects orbiting above your head. To understand the danger, you have to understand space debris. The space age began in 1957, when Sputnik beeped its way across the sky. Since then, we've launched thousands of rockets, satellites, and probes. Some came back, many didn't. Old rocket stages left drifting, dead satellites that ran out of fuel or failed, fragments from explosions and collisions, bolts, panels, even tiny flecks of paint. Today, space agencies track more than 30,000 pieces of debris larger than a softball, and they estimate more than 1 million pieces between 1 and 10 centimeters. At orbital speed, any one of them could destroy a satellite. In low Earth orbit, objects move at around 7 to 8 kilometers per second. That's more than 10 times faster than a rifle bullet. A metal screw the size of your fingernail can punch a hole straight through solid aluminum. We've already seen what can happen when things go wrong. In 2007, a Chinese anti-satellite test shattered an old weather satellite, creating thousands of fragments. In 2009, an inactive Russian satellite smashed into an active American one, Iridium-33, spawning yet another debris cloud. Each collision made the problem worse. Now, add Starlink to this picture. SpaceX has already launched thousands of Starlink satellites. In the long term, they've talked about tens of thousands. If you could see them all at once, it would look like a glowing shell of metal around the Earth. More Starlink satellites are now in orbit than the total number of all other active satellites just a few years ago. And other companies and countries want their own constellations too. OneWeb, Amazon's Project Kuiper, national systems from multiple countries, all adding their own swarms to the sky. In just a decade, low Earth orbit has gone from a quiet neighborhood to the world's busiest highway. And like any crowded highway, one crash can cause a chain reaction. In 1978, a NASA scientist named Donald Kessler described a terrifying scenario. Imagine, he said, that space becomes so crowded with satellites and debris that one collision triggers another, and another, and another. Each impact creates more fragments, more shrapnel, making future collisions more likely. At some point, the chain reaction becomes unstoppable. We call this the Kessler Syndrome. A runaway cascade of orbital debris that could render certain altitudes practically unusable for decades or longer. This isn't science fiction. Even today, the International Space Station regularly performs avoidance maneuvers to dodge pieces of junk. Satellites receive warnings and adjust their orbits to miss debris by a few hundred meters. Every year, the number of these close calls goes up. Now imagine a future where not thousands, but tens of thousands, or even hundreds of thousands of satellites circle the Earth, every one of them a potential bullet. Every failure, every explosion, every careless design decision, adding a new cloud of fragments to the sky. In the worst case, we could trap ourselves under a man-made meteor storm. So where does Starlink fit into all of this? To their credit, SpaceX is not ignoring the problem. Starlink satellites are equipped with ion thrusters that allow them to maneuver and deorbit themselves at the end of their lives. They're designed to automatically burn up in the atmosphere within a few years after they're shut down. They also use automated systems to dodge known debris using tracking data from the US Space Command and other sensors. But automation isn't perfection. Software can glitch, communication can fail. Solar storms can scramble electronics. And even if each satellite has a low chance of failure, when you have tens of thousands, rare failures stop being rare. What happens if just a small percentage of a mega-constellation becomes uncontrollable? You suddenly have hundreds or thousands of dead objects in similar orbits, moving fast, crossing paths. That's not just one more piece of debris. That's an entire new layer of risk. There's another kind of loss here too, one that's harder to measure. For astronomers, the night sky isn't just beautiful, it's data. Telescopes rely on long exposures, minutes or hours of gathering faint light from distant galaxies and nebula. Long trails of bright Starlink satellites cutting across those images can ruin them. Astronomers are already reporting streaks across their photographs, lost observations, disrupted surveys of near-Earth asteroids. We used to look up and see the universe. Now, more and more, we see the machinery of Earth. SpaceX has tried to respond. They've experimented with darker coatings, different orientations, designs to reduce reflected sunlight. But as the numbers climb, even faint satellites add up. There's a quiet grief in the idea that a child born today may grow up under a sky permanently marked by our technology. It's important to be fair. Starlink isn't just a threat, it's also a lifeline. In remote regions, it can mean the difference between having an education and being cut off from modern knowledge. For hospitals in rural areas, it can support telemedicine and emergency communication. In war zones and after disasters, Starlink terminals have kept people online when cables were cut and towers destroyed. For millions, connectivity is not a luxury, it's survival. So we face a hard question. How do we connect the world without breaking the sky? First, we need rules. For most of the space age, orbit was treated like a frontier, open, empty, and limitless. That illusion is gone. Low Earth orbit is a shared resource like the ocean or the atmosphere. We need international agreements that limit how long dead satellites can stay up. We need strict end-of-life plans for every new satellite, especially those in mega-constellations. No more leaving scrap metal up there indefinitely. Second, we need better tracking. Right now, most debris is tracked by a few national systems, with data that isn't always perfect or shared instantly. Imagine a global air traffic control for orbit, where every operator can see precise real-time positions and planned maneuvers. That would make it easier to dodge collisions before they become headlines. Third, we may need to clean up the mess we've already made. Engineers are testing nets, harpoons, robotic arms, and even tug satellites that can grab dead objects and drag them down to burn up safely. Active debris removal is still experimental, but if mega-constellations become the norm, cleaning the sky may become as essential as cleaning the oceans. And what about you? Why should any of this matter to a person watching a video down here on Earth? Because so much of your life already depends on space. GPS satellites guide planes, ships, and even the phone in your pocket. Weather satellites warn us of hurricanes, floods, and heat waves. Communication satellites carry news, bank transactions, and emergency calls. If low Earth orbit becomes too dangerous to use, it won't just affect telescopes and rockets. It will affect food on shelves, flights in the sky, ships at sea, and the safety of people you love. The truth is simple and uncomfortable. We are the first species to wrap our planet in a shell of machines, and we are the first species that can ruin its own sky. Starlink is a symbol of what we are: brilliant, restless, hungry to reach every corner of the world with our signals. It shows our ability to solve huge problems with bold ideas and pure engineering, but it also exposes our old habit of pushing limits first and asking about consequences later. One day, when someone looks back at this moment in history, they might ask a simple question. When we turned the sky into an extension of the internet, did we do it wisely? Did we protect the silence between the stars? Did we keep space open for the generations that came after us? Or did we trade a clear sky for a quick connection? Right now, nothing is inevitable. We still have time to write a different story, a story where mega-constellations bring knowledge to the most forgotten places on Earth, and where strict rules, smart design, and global cooperation keep our orbits safe. A story where decades from now, a child can go outside, look up, and still see the Milky Way. Even as invisible beams of data pass overhead, Starlink and the space debris crisis are not separate tales. They're both chapters in the same book: how a young, clever species learns to live with its own technology. The satellites will keep going up. The question is whether our wisdom can rise with them